Alright, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, my name is Dr. Umashankar and I'm your physics educator. And in this session, guys, what we are going to do, so in this session, we are going to continue with the projectile motion. So, in the last session, guys, we have completed the ground to ground projectile motion. Okay, in the last session. So till this point we have completed ground to ground projectile motion, ground to ground projectile motion. Okay, we have completed this previously and we have also completed equation of trajectory. Okay, so we have seen that how we can use the equation of trajectory, right? So we have seen equation of trajectory also. Okay. Okay, so this much we have completed till this point. Okay, now in this session, guys, we are going to begin with the projectile motion from an height. Projectile motion, projectile motion from a height. Okay, projectile motion from a height. Okay, now how we got to do this? Okay, now please understand this. So see, there is no new. So lastly, we have, like in projectile motion, I have given you all the concepts. So before you watch this video, if you are watching this video, if you are not live, if you are watching this video, if you are watching this video, remember that you need to, you need to basically watch the previous sessions, that is part one of this. Okay. So as I was saying, you need to watch before you watch this video or before you come to this session. So you are supposed to watch the projectile motion part 1 and projectile motion part 2 before this video. Okay. Because see, this is, like in this session, we are not going to use any new concept, but we will be using the same concept as that of the ground to ground projectile motion, okay, or the equation of trajectory. So see, in this case, what is going to happen? So when projectile motion we are talking about from a height, so now in this case what happens? So we are having, let's suppose we are having a tower. Let's suppose we are having a tower. Okay, and now from this tower, so see, what is projectile motion from a height? So in this case, basically, you are doing the projectile thing from from some height. Okay, okay. So let's suppose we are having a tower or something whose height is something. Okay, like h. Now this is shown from this very height. So if it is shown from this height, it, let's suppose it is shown with a horizontal velocity, and obviously it can have a velocity with some inclination to the horizontal as well. Now let's first talk about this case. Now when we are throwing it with, or when we are letting it go with a velocity of some horizontal velocity, let's suppose u. So this is going to be following a path like this. This is going to follow a path like this. This is going to follow a path like this, right? A path like this, and this is u. Okay. Now, when it is going to follow a path like this, it is going to strike the ground at somewhere near, let's suppose, this point. Okay. Okay. Now, please understand this. So, there is nothing new in this case. It is exactly the same. And as I said, see, projectile motion is not at all a new, not at all a new topic. Okay. It is not at all a new topic, but it is, like you see your what your motion under constant gravity. This is extension to that only. This is merely extension. Yeah. So as I was speaking, so now please understand this. So now in this case, see what is going to happen. Now in this case, what is going to happen? So now in this case, what is going to happen, guys? So in this case, you are going to have the velocity it is thrown at a horizontal velocity u. Okay. Now we understand that in x direction there is no acceleration. Now in x direction, when there is no acceleration, guys, will there be any change in the velocity in x direction? No, sir, there will be no change in the velocity in x direction, right? Because there is no acceleration in the x direction, similar to the motion, ground to ground projectile motion. In there also, there is no change in the velocity in x direction as that of the initial velocity, right? So initial velocity in x direction remains same there also. It remains same here also, right? So this is going to be u, and u, right? Now, what about the velocity in y direction? So all this thing we have done previously also. Na? I don't think that it is going to give you any big burden on your mind because we already have completed all this thing. So horizontal component of velocity is u. So what is the acceleration in x direction? So if I try to figure out the motion in x and y direction, okay, in x and y direction. So now in x direction, in y direction. So in x direction there is no acceleration whatsoever because like acceleration due to gravity, it doesn't act in x direction, that is horizontal direction. What is ay? It is always downwards, so this is going to be minus of 10, okay, or minus of g, whatever. Okay, minus of g. Now, since initial, now please understand this. So, initial velocity is in the horizontal direction. Okay, so there is no vertical velocity. That is, initially in this case, I can assume that Vy is equal to 0 because see, u is horizontal. When it is horizontal, there is no component of it in vertical direction. See, what I always tell you, so you need not to, memorize everything here. You need not to memorize it, beta. Okay, just be good with your basic concept. Okay, what would have happened if this initial velocity would be at some angle with the horizontal? Then you must have to take the component of that velocity in x and y direction. But in this case, what is there? It is only having a horizontal velocity. So when it is only having horizontal velocity, initial velocity in y direction is going to be 0. Now, what is going to happen to the velocity in y direction? So, since the acceleration is minus g, that is acceleration due to acceleration is downward. So, acceleration is downward. So, initially velocity is 0, but due to this acceleration, this velocity will increase. Okay, it will going to increase, right, in this negative y direction. Do we agree to it or not? Because acceleration is there na, in downward direction. So when acceleration is there in the downward direction, what it will do? It will increase the velocity in y direction. It will increase the velocity in y direction. I hope it is fine to everyone. Right? Okay. Okay. Now, what we have to do? Sir, are we going to develop some new formula? Are we going to memorize some new formula? No, no, not at all needed. Not at all needed. You can go by your basic equation. So let's understand this with the concept. And again, I'm telling you, if you haven't seen the projectile motion part 1 and part 2, please do watch them. Then only you will be able to understand this particular topic. Okay. So let's take some questions and we'll try to understand with the help of questions only. So this is, let's suppose, 20 meter. Okay. And this is going to be like this. Okay. So let's suppose a ball is thrown or a body is thrown, a particle is thrown, whatever, at 5 meter per second velocity. So it is moving with a 5 meter per second velocity. It moves with a 5 meter per second velocity and it is going to reach the grounds at some. So what is to be found? So let's start finding out one by one. So I'll make it like a question now. Okay. So one way I could, develop a formula or something, but I'm not going to do this time. Okay, see, this is going to be 5 meter per second. Okay, 5 meter per second. This is, let's suppose it is thrown. So this is obviously going to be like this. Okay, going to be like this, and this is going to be, so first thing that we have to find. So find the time taken by projectile. Find the time taken by projectile to reach the ground. Projectile to reach ground. Okay, please go for it. Please answer it. Yeah, very good, she say. No. So what is the time taken to reach the ground? I am asking. You are saying, sir, 5I plus 20J. What is the time it take? Hello, she's saying. No, 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 no. That will be asked later. What is the time it requires projectile to reach the ground? How much time it is going to take? That is what I am asking first. How much time it is going to take? Hmm? No, no, actually, the buffering that happened was from my side. So I just corrected it. Yeah, sometimes see it happens now. Okay. So what is the time taken for this projectile to reach the ground? So in what time it is going to reach the ground, my dear? So this is 5 meter per second. See what we have to do. So no new concept will be required. So what we are going to do, we are going to use our old concepts. So see, let's suppose this is A. Let's suppose this is B. Let's suppose this is A. Let's suppose this is B. So now from A to B, from now A to B. So from A to B, what is the initial? So I'll consider the motion in the y direction. So in previous, oh, okay, understood, Shishai. So Vy is equal to 0. Vy is equal to 0. Initial velocity in vertical direction is 0. Okay. Now what is the displacement? Displacement is minus 20 meter. What is the acceleration? So in downward, the acceleration is minus 10. Okay. So it is uy actually, not vy, uy. Initial velocity na uy. Uy is equal to 0, sy is equal to minus 20, and ay is equal to minus of 10. Right? Minus of 10. Yeah, Shishai, very good. So now see, did we do anything new here? So we are going to use those same equation that we have been using quite from a time. Okay. So that is why this whole thing I call it as kinematics. It is not like motion in a plane can also be solved with those equations only. So from here, can I write Sy is equal to Uyt plus half a t square. This equation we learned to use. So this is going to be minus 20. Uy is 0 minus half. What is g? It is 10. And t square. And t square. So from here, t is going to be plus minus of 2 seconds. So plus minus of 2 seconds. That means t is 2 seconds. So it is going to be find the time taken by projectile to reach the ground. So it is going to take 2 seconds to reach the ground. Right? Okay. Now let's move forward. Now let's do the second part of this question. Let's consider the second part. So in the second part, we need to find the horizontal range. Find the horizontal range. Let's find the horizontal range. Okay. So what is going to be the horizontal range? So obviously this is what is the horizontal range now R. Can you find me the horizontal range, please? What is the horizontal range? Very, very simple, sir. So for finding the range, we need to consider the motion in x direction. So if I consider the motion in x direction, so Sx is equal to ux into t plus half ax t square. So what is going to happen? So xx, what is the horizontal range? That is r. What is the ux? It is 5. And in what time it reaches this b? It is 2. So r is going to be 10 meters. So the horizontal range, it is going to be 10 meter. I hope it is fine to everyone. Yeah, please answer me. Yes, sir, definitely it is fine. Now let's do the third part of this question. So now in the third part, if I say, so find the velocity, find the velocity of ball, find the velocity of ball when it hits the ground, when it hits the ground, when it hits the ground and its speed. Okay, so what it has, so see, eventually when it is thrown from this, so it is going to be striking the ground at some point of time. So at what will be the speed, then that is asked in this question. Can we please try it? Let me do it. Okay, so now see, we want to find the velocity at b. So many students make mistake here. Okay, so let's see what could be the possible mistake in this case. So now in this case, see what happens. So many students say that the velocity, so they end up finding only the velocity in y direction. Now one thing is very clear. See, velocity at b. So when it will strike the ground, that means the velocity when it hits the ground, the velocity is going to be. So see, what is velocity, sir? It is a vector. So when it hits the ground, it must have two components of velocity. One is in x direction, one is in y direction. So u I cap plus v j cap. So this is going to be 5 I cap plus vj cap. So what is v? So it is velocity in y direction. So how we can find the velocity in y direction? So what is the final velocity in y direction? Let's suppose it is Vy. I am considering the motion from A to B. Okay. What is the initial velocity? What is the initial velocity? That is, so we can use this equation now. We can use this equation, or we can use this Vy is equal to U, because time we already have. Time we already have sorted now. So Ay into T. Okay, so Vy will become, see, Uy is 0. What is this Ay? It is minus 10. And what is this T? So T is 2. T is 2. So this is going to be this is going to be, Vy is going to be minus 20. Okay, Vy is going to be minus 20. And obviously this minus sign refers to what? This minus sign is negative z direction. Negative z direction. So what is this V? What is this V? So this VA, no problem, no problem. In phone you can type, yeah. So this is going to be like this. So it is going to be minus 20 of j cap. Okay, so what is going to be the velocity? So many students, they do what now? They just think of the motion in the y direction only, and they end up saying that the velocity is 20 j cap or minus 20 j cap or just 20, right? But this is not true. When velocity is asked, my dear, so this is not done now. The velocity, when velocity is asked, you have to give it in the form of vector. So see, at the point where this ball hits the ground, this is going to be the velocity vector. And what is the speed? So I know, sir, speed is what? Sir, it is root over 5 square minus 20 square, that is 425. 425. Is that clear, Beta? Please answer me. Is it fine? Right. So now in this, did I do anything, that troubled you? Okay. Now in this very case, if it is also asked that what is the angle, what is theta? I suppose this is also asked in the very question. What is the theta? What is the theta? What is theta? Or what is the angle? What is the angle with which? What is the angle with which ball strikes the ground? Okay, ball strikes the ground. So what is the angle with which the ball strikes the ground? Hmm? Can you answer me that? Minus 20. So it depends upon the reference that you have taken. Na? So see, obviously, sir, this is what going to happen there, right? This is what going to be happening. So sir, we have just sorted that at B, the components of velocity are this, so 20 j cap, that is 20 in this direction, and 5 in this direction. 5 in this direction. Okay, so what is going to be the resultant? So the resultant is going to be somewhat like this. And if we say this is theta, this is theta. So see, if this is theta, this is going to be, so we can write tan theta is equal to 20 by 5, right? Tan theta is equal to 20 by 5. Okay, so it is going to be, theta is going to be tan inverse 4. And remember that we have taken this theta from the horizontal axis in clockwise direction. Fine, beta? Please answer me. Boliye. Is it fine? Right, wonderful. Now, it is also always not necessary. It is also not always necessary that we, drop something from a height, or we do the projectile motion from the height with initial velocity in horizontal direction. We can have the velocity at some angle as well, right? Can't we? Yes, so definitely we can. So now let's us understand this. So see, I always say there is no new concept, there is no new formula, just it is being the same. This is 20 meter, this is 20 meter, and it goes like this. And let's suppose that we have thrown something, or we have done the projectile with a velocity of 30 meter per second, and this is at an angle of 30 degree. This is at an angle of 30 degree. Okay, now you have to find the time, find the time with which it hits the ground. Okay, time with which it hits the ground. Second, you need to find the horizontal range. Find horizontal range. Okay, then we have to find all the same things. Okay, all the same things. So final velocity and speed. Okay, and lastly we have to find theta at which it hits the ground. At which it hits the ground. Okay, now let's try these questions. Can you please tell me? So what is going to be the answer to this? What is the first part? Find the time with which it hits the ground. Can you tell me? In the same way we have to do it. No, wrong answer. Precise. So please move in the order. First you tell me please, first you tell me the time. No, wrong answer. Wrong answer, my dear. What's getting wrong? Please use your basic concepts, Vida. Please use your basic concepts. See, there is nothing in this question that you can't do actually. I'm waiting. See, in projectile motion, that is in two dimension, you have to break your motion in x direction and y direction. Yes, I'm waiting. Please wait. Yes, I'm waiting on Linda. What is the answer to this? See, very simple. There is nothing in this question that you can't do. See, they can ask you anything if you are using your basic equation. There is no problem at all. Just use your basic equation of motion with the sign convention. It is, see, projectile motion is nothing. No, again, wrong answer. I'll do it now. Please observe. So now you understand this. First of all, this is going to be like this now. This is going to be like this. Okay. It will move in this direction, this, and it is going to, strike the ground somewhat like this. Okay. Now what happens? So now it 30 meter per second has two components. This is a component of 30 sine 30, that is 15 meter per second, and this is 30 cos 30. So cos 30 is root 3 by 2. Okay, so I can write 15 root 3. Is it fine, madam? Please answer me. 15 root 3. I'll just do so that you can understand this. I'll just take it to the next page. Just a moment. Okay, let's try this one. No, wrong. Just let us see it. So now, do you agree to this? So since it is shown at 30 degrees, see, we have to follow our basics. Okay, so it is like some of the vector, sum of motion in the straight line. Okay, that is the equation of motion. So this is 30 cos 30. So 30 cos 30, that is root 3 by 2. That is 15 root 3. And this is going to be 30 sine 30. That is 30 into 1 by 2. That is 50. Okay. Now again, as usual, I have to break it down into this two kind of a motion. Now let's suppose this point A, this is point B. Okay. Now if I consider the motion between A to B, if I consider the motion between A to B, so I can write, and I am talking about y direction. So we can write Sy is equal to Vy t or Uit plus half Ay t square. Okay, can we do that? Please answer me. T is 4. Now you have got it correct. Okay, so what was the mistake that you have been doing since so much time? So Sy is minus 20. What is Uy? It is 15. So T we don't know. T we don't know. Plus 1 by 2. What is Ay? Ay is in this. Ay is always in negative direction. G is always in negative direction. So this is minus 10 T square. Now how much it is going to become? So it will become 5 of T square minus 15t minus 20 is equal to 0. Minus 20 is equal to 0. So can we write t square? Can we write t square minus 3t minus 4 is equal to 0. Minus 4 is equal to 0. So from here we'll get t is equal to 4 and t is equal to minus 1. So t minus 1 cannot be the answer. Okay. T minus 1 cannot be the answer. So what is going to be the answer? The answer is t is equal to 4 seconds. Right? Isn't it? Yes or no? Now, what was the mistake that you have been doing into this? Can you tell me that? Yeah. So physics you have to do a little bit patiently. Now let's come to the second part of the question. Find horizontal range. So for horizontal range, what sort of a motion we have to consider, sir? What sort of motion we have to consider? So for horizontal range, sir, what we can do? Again, we can consider motion from A to B. Now, when we consider the motion from A to B, I can see that Sx displacement, we understand that it is uxt plus half axt square plus half ax of t square. Now we understand that there is no acceleration in horizontal direction. So when there is no acceleration in the horizontal direction, this is going to be 0. Now what is going to be your Sx? It is going to be 15 root 3. 15 root 3 into what is the time? This is 4. Okay, so it reaches the, it hits the ground after 4 seconds. It hits the ground after 4 seconds, right? Okay, so this is going to be how much? This is going to be 60 root 3 meter, isn't it? Now, do we require any formula to solve this question? If you see, like, go conventionally, you will find a formula to these also. But do we require any formula, sir? If we are using our basics only, then also we can do with it. Yes or no? Please answer me. Right? Now, let's come to the velocity when it hits the ground. Okay? Velocity, find velocity and a speed, final velocity and a speed. That means the velocity and a speed when it hits the ground. So please understand this. Okay, let's suppose the third part. Now, in the third part, what is going to be the final velocity? So there will be two components. One is x direction, one is y direction. So final velocity, that is the velocity at which it hits. So final velocity, let's call it v vector. So v vector is going to be, so we understand that velocity in x direction is not changing because there is no acceleration in x direction. So right away I can write that it is going to be 15 root 3 I cap. Okay. Don't forget, don't you ever forget about this x component. What we think, sir, we have to find the, we'll try to find the vertical velocity and we let go of this. Okay. The horizontal component. Don't do that. Right, don't do that. And now, see, this is 15. This is 15. Now, if I consider the motion in y direction, so if I consider the motion between A to B, if I consider the motion between A to B in a y direction, let's say in y direction. Now, in y direction, when I assume this thing, so what is going to be? So, velocity, final velocity in y direction, it is initial velocity in y direction into t into ay into t. So, what is going to be the final velocity in y direction? It is going to be 15 of t, that is 4, and acceleration. Oh, I always do this. I start writing the equation, then I do it wrong. Uy plus ayt. Sorry. Okay, my bad. Yeah. So now uy plus ayt. So vy, what is the final velocity? So initial velocity in y direction is going to be 15. This is going to be y, that is 10, and this is going to be 4. Time is going to be 4. So this is going to be minus 25 meter per second. So can I write here minus 25 of j cap, minus 25 of j cap, right? So this is going to be your final velocity vector. So in projectile, remember the final velocity will have both I and j components of the vector. Okay. So there is some, internet issue today. Okay. Yeah, some sort of internet issue, actually not from my end. It's basically buffering from my end only. I don't know what is happening. Okay. have a good internet connection, everything is there, but sometimes you never know like what can happen, right? So, anyways, okay. So what is going to be the final velocity vector? So it is going to be the final velocity vector. So what is going to be the speed, sir? This is going to be 15 root 3 whole of a square and minus 25, sorry, plus 25 whole of a square. So this is going to be your, what? This is going to be your speed. Understood? No, 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 no. She's saying it is actually from my end. Okay, so some, I don't know, because see, I can see that because I keep watching the video performance, so like some streaming issues are there. I don't know why it is there. Sometimes it happens. Yeah, see, it is not in control of anyone right now. So you can't do anything about it. Okay, so sometimes it happens, and like what can be done? We can't do anything actually to this. Anyways, okay. So now this is found. Now what is the angle? What is the angle to which with which is a strike? Hello Anirudh, welcome to the session, my dear. So we are dealing with the projectile motion right now. Okay, so Anirudh, I'll tell you. So basically, we at this channel, I'm the physics educator. My name is Dr. Umashankar, and we are trying to cover the physics as early as we can. And basically, in this direction, we are right now moving into motion in a plane. Previously, we have completed the motion in a straight line completely. Okay, and motion in a plane, we have done the vectors comprehensively, and now we are dealing with the projectile motion. Afterwards, we have these two left topics left, that is 2D and relative velocity in two dimension and circular motion. Okay, so anyways, so we are dealing with the projectile motion right now. So theta at which it hits the ground, so we can say tan theta. So vertical component of velocity, that is 25 upon 15 root 3. Okay. Okay. But do remember that when I am neglecting the sign, so I am assuming what? I am assuming this. This is, 15 root 3 and this is 25. This is 25. So this is going to be your theta. Right? 25 by 15 root 3. Is it fine? Will you please answer me? Please tell me yes or no. Okay. Okay. Understood? Very easy, right? Okay. So now this also you will be able to deal. Now you tell me one thing, okay? Because see, there is some fluctuation in the net. So let's conclude this. One case is still left. Inclined plane. Okay, we'll see what to do. Now it is not always necessary that we throw something horizontally or upwards only. We could throw it like this also. Now let's suppose we are leaving it as 30 meter per second, like this, 30 meter per second, and it makes a velocity of 30 degree. It makes an angle of 30 degree with the horizontal. So now how it is going to strike there? It will strike like this. Okay, it will strike like this. Okay. Now in this case also you can find all these things or not. Please answer me. Now let's suppose I say that this is, let's suppose this is also given 25.9 meter. This is given 25.9 meter. You need to find the h. Can you please try it? You need to find the h. Can you try it, please? How you got to do it? how you got to do it. What is the height of this tower? So something can be thrown like this also. That's right, beta. I don't have the answer to this. Just make the question now. How we can do it? So see, what I'm trying to infuse into you, projectile motion happened to be ground to ground. It happened to be from some height. From some height, if it is thrown horizontally to some inclination, from horizontal, upward or downward, any way you can be able to do it. This is what I want. This is what is my motive with this. So how we can do it, Beta? How we can do it? So this is 30 meter per second. This is 25.9. We need to find h. So again, let's do it in the same way. So we can take the component of it in this direction. So this is going to be 30 cos 30, and this is going to be 30 sin 30, isn't it? Okay, 30 sin 30. Okay, let's do like this. So obviously, so this is going to be 30 cos 30. So 30 cos 30 means it will become 30 into root 3 by 2, that is 15 root 3. And this is 30 sin 30. So 30 sin 30, this will become 15. This is going to become 50. Yeah, I'll see to it. What is this edge? So now we have both horizontal and vertical component. Now again, what we have to do, let's consider the motion. Let's suppose this point is A, this point is B. So we have to consider the motion from A to B in x direction and in y direction. In x direction and in y direction. So in x direction, when we are seeing it, what is going to be this motion? So this motion is going to be, so what is the displacement in this direction? So we understand Sx is equal to uxt, and there is no acceleration in x direction. So there is no acceleration. So from here, what we can do? So 25.9, what is the initial velocity? It is 15 root 3 of t. So from here, you'll get the t, right? From here, you get the t, isn't it? Right? Will you know, yes or no, beta? Will you be able to get t from here? Yes, sir, absolutely. Now, in the y direction, what we are going to do? So I can write it as minus h. Displacement in y direction is equal to, I'm using this equation, sy is equal to uy into t, uy into t plus half a t square. So it is going to be minus h, uy is equal to 15t, okay, plus that is minus half Now this 15 is downward direction, so we'll have to take the minus. Don't forget about the sign also, right? Because this 15 is downward now. So downward vectors are to be taken as negative. This h is also downward from A. I have considered the A as the reference. So h is minus, this is also minus, and g is always minus. So this is going to be minus t square. So what we can do? What we can do, sir, we can put the value of t here. We can put the value of t here. And once we do that, we'll get the h obviously. Boolean. Once we do that, we get the h obviously. Is that clear? Would I please answer me? Can you answer me on this? Acha, acha. So it is like 1 second. Okay, okay. That's fine. Right? You got the concept, right? That is the main thing. Clear? Okay, wonderful. So, see, due to some fluctuations is there, so I'm not continuing because I wanted to anyway complete this today, but I think see what is the point when there is some problem. So I'll do one more video out of it, and we'll complete the projectile motion in the incline in the next session. Okay, right? Fine. Sounds good. Yeah. Although there is no new concept in there, the concept remain the same, right? Or we can do in the 75 hard day challenge thing, considering it as the question, whatever suits us. Okay, so we'll do in that. I'll see to it. I'll see to it. Okay. So see, projectile motion on the inclined plane is left to be completed. We are going to do that. And see, there is no new concept. The same concept is going to work there also. And we are going to very easily understand that thing as well. So guys, I'll keep it to this session, keep it to this point in this session. So with this, thank you very much. Have a good day and we'll see you in the next session.